We're going to end this section off with that hence question, where you have part A and part B. Part A is fairly simple, but then part E, containing the word hence, means that you need to use what you've discovered in A in order to work out B. And a lot of people struggle to find the connection, so I'm going to try to make it as simple as possible today. So looking at section A, where we're going to solve this equation, we have a denominator, but there is only one denominator, so we just have to multiply out by that. I always advise people to write down what they have on the left-hand side before you start. So x minus 3. And then, because I'm going to be multiplying the left-hand side by the denominator, that denominator is simply going to move across to the right-hand side by cross multiplication, because there is nothing to cancel with it. And don't be confused that they're both x minus 3s. This x minus 3 that I've written down here is what I had on the left-hand side. And now through cross multiplication, this one is also going to come up to the left-hand side. So I'm going to have 2 of the same bracket. When I multiply this term by the LCD, the x minus 3s are going to cancel, and I'm simply going to be left with 4. This question's got lots of little things that can trip you up, and here's the next one. Whenever you see these two brackets in what looks like a quadratic equation, people tend to get all excited. Oh, it's already been factorized for me. But look very carefully. That does not say equal to 0. And you only towards the end of the equation when that says equal to 0. So you actually have to multiply out these brackets, bring the 4 across, and then refactorize with a 0 on the right-hand side. We have done a previous question in one of the episodes where something like this cropped up, so you should be aware of it by now. So multiplying out these two brackets, x times x, my outers are going to give me negative 3x, my inners are giving me negative 3x, so I've got negative 6x, and my outers negative 3 times negative 3. And I want to bring that across because I see that it is quadratic, so I know that I need to gather everything onto the left-hand side, and the right-hand side has to be equal to 0. So tidying this up, 9 minus 4 is 5. Right, a fairly easy equation to factorize, because again I have a prime number there, so I'm going to have x and 5, x and 1. The signs in the brackets are the same and they're both negative. I'm going to make note of that step because I'm going to be using it just now, but I have actually been asked to solve for x as well, so I need to finish off. Either this bracket equals 0 or that bracket equals 0, which means that either x is equal to 5 or x is equal to 1. And always when you get down there and you've had a denominator, double check, did you remember to do your restriction? If you've forgotten to do your restriction, you go back, look at your denominator, it contains a variable. What variable would make that denominator equal to 0? X may not be equal to 3, because 3 minus 3 would be 0. Looking at my restriction and my solutions, it's fine. So I do have two solutions to my quadratic equation. So now I'm going to go across to the hence part, and that means use part A in order to, this looks pretty complex. If I think of multiplying out, I'm going to end up with y to the power of 4, which we're not working with at this stage. So what will normally happen is that there'll be some kind of common thing happening between these two equations. So if we look, this left-hand side ends off with a minus 3. That left-hand side also ends off with a minus 3. That numerator is the same. This denominator ends off with a minus 3. So there's a lot in common. So if we look at what's not in common, this is in the same position as that is over there. And this is in the same position as that is over there. And these are both x's and those are both y squared minus y's. So we can equate or substitute x with y squared minus y. And that's why I want to go back to this section. If I start from here, I've got to do a whole lot of unraveling. If I go back to where I've set my two brackets equal to 0, it's going to make it nice and simple to proceed. So I'm going to rewrite this bracket, but instead of an x, I'm going to put y squared minus y. So that was instead of the x, but I still have minus 5. Then if I go to the other bracket, instead of the x, I'm going to write y squared minus y, and I still have the minus 1. Right, so at this stage it's saying this bracket has to be equal to 0, or that bracket has to be equal to 0. But if you look at each bracket now, both of them are quadratic equations. So I actually need to solve this quadratic equation, which will probably give me two solutions, and I need to solve that one, which could also possibly give me two solutions. So let's have a look at trying to solve this, factorize it into two brackets. So I've got factors of 5 that have to give me 1. Well, my only options are 1 times 5, and there's no ways that a 1 and a 5 can give me a 1. So straight away, I'm here with a quadratic equation that doesn't factorize with the cross method, and so I need to use the quadratic formula. Factors of 1, 1 times 1. Can 1 and 1 give me 1? No. So now I've got two situations where in both cases I have to use the quadratic formula. So let's deal with this one first. When you're doing this type of question, you're at the stage where you are advanced in your maths, so I'm not going to put in all the little bits and pieces to prompt you. I'm going to prompt you orally, but you need to be able to work without putting in all the little steps now. So remember that your quadratic formula says negative b plus minus square root of b squared minus 4ac all over 2a. So I'm going to jump straight into that now. So my b is negative 1, but I want negative b, so negative 1 will be positive 1. Remember, it has to be plus or minus the square root. So the square root of b squared, negative 1 times negative 1 is 1, minus 4ac. So minus 4 times 1 times negative 5. So negative times negative is going to be positive. 4 times 5 is 20. Over 2a, 2 times a, which will be 2 times 1. Let's simplify that down a little bit. 1 plus or minus the square root of 21 over 2. So if you feel that that might be able to be simplified a bit, you could punch it into your calculator, but I can tell you now that square root of 21 can't be simplified. If they asked for the answers in decimal form, specifically asked for the answers in decimal form, you would punch this into your calculator and take the decimal answer. But usually they will want the answer in surd form or actually request it in surd form. So let's do the exact same thing with the other bracket. So negative b, negative 1, again is positive 1, plus or minus. B squared, so negative 1 times negative 1 is 1, minus 4ac, minus 4 times 1 times negative 1, negative times negative is positive, and 4 times 1 is 4, over 2 times 1 is just 2. So again, fairly nice and simple. I'm now looking at the square root of 5 over 2. So here I do have two solutions because it's 1 plus that square root over 2 or 1 minus the square root over 2. Same thing there. So I've ended up with 4 solutions by looking for the similarities in that more complex looking equation. So if you think about it, we're actually using the K method because we're setting this equal to x just like we do with the K method. I hope that was helpful. I hope you'll be able to solve hence problems more easily in the future. And if you like this, I ask you to subscribe so that my future videos will pop up easily for you. Thank you.